Okay, let's take a look at a problem from Achieve section 3.9. I think it's number 18. Your problem should look very similar to this. It's basically find the derivative of this function. And this function, the derivative cannot be found by the normal methods of differentiation that we've developed so far. There's no product rule going on here. There's no quotient rule. It's not a power rule because the base x it's not a power rule because the exponent 5e to the 8x is not a constant, and it's not an exponential function rule like 2 to the x or e to the x because the base is not a constant. Basically, you have a function of this form where the base is a function of x and the exponent is a function of x. These types of functions must involve the use of logarithmic differentiation to find the derivative. Logarithmic differentiation, you basically take the natural log of both sides and then apply these properties of logarithms. I developed these in the lecture video, of course. These should be familiar to you from pre-calculus, but in this particular problem, the third property here, where you take the natural log of a to some power, that's going to be that power n times the natural log of a, because basically, again, logarithms are exponents. So when you raise a exponential expression to another exponent, you multiply the exponents together. And remember, the logarithm, natural log, again, is the exponent on the base, in this case, e, needed to get a. So you're multiplying the exponents together. Okay. At any rate, that's what we're using. Okay, so the first step, of course, is to take the natural log of both sides of this. And then on the right-hand side, we'll use this property. You have x as the base. The exponent is 5e to the 8x. That exponent 5e to the 8x comes in front. And then I put a little dot there to remind we're multiplying now, right? So you have a product. And now I can find the derivative here. Of course, I'm going to find the derivative with respect to x. Over on the right-hand side, it's just the product rule. So I've changed it from an exponential expression into a product. And that's the neat thing about these properties of logarithms that allow us to essentially simplify the function and then differentiate. Okay, so the process of differentiating with respect to x of both sides. Let's go to the left-hand side first. What's the derivative with respect to x of natural log of y? Well, remember, y is a function of x. In fact, we know exactly what function of x it is here, but it's chain rule, right? You've got the derivative, the outer function is natural log. So the derivative is 1 over what? The inner function y times what? The derivative of the inner function. What's the derivative of y with respect to x? It's dy dx, right? The derivative of y with respect to x, right? We'll be doing this all the time. We did this in implicit differentiation, and we continually use this idea, right? When we take the derivative, essentially using the chain rule, you'll have the derivative of the outer function times the derivative of the inner function. This dy dx comes into play. And that's important because that's what we're looking for. That's what we're trying to find, dy dx, the derivative of the function y here with respect to x. Now on this side, I'm going to use the product rule. So I have the derivative of 5e to the 8x times the natural log of x plus 5e to the 8x times the derivative of natural log of x. The derivative of 5e to the 8x, the 5 is a constant multiple. E to the 8x derivative is a chain rule. So you have e to the u, which is e to the 8x times the derivative of the inner function, which is 8. So this will be 5 times 8, 40 e to the 8x. Derivative of natural log of x is just 1 over x. Okay, so now to solve for dy dx, I can multiply both sides by y, right? Multiply by y, so y is here. And then in parentheses, I've got, as I said, 40 e to the 8x times the natural log of x, and then 5 e to the 8x times 1 over x is this, right? Then y, remember, we can express the derivative if we can. We would like to express it in terms of x only, and we can because y, remember, was this function here. So I just replace y with this stuff here, right? X to the 5 times e to the 8x power. So this is what we get. Now, let me just say a word of caution. I've noticed in Achieve, it doesn't seem to like this response. Okay, if you had that problem and you don't want to redo it, I would have to go through and check and see that that was one of your answers, and then I can go back in after the fact, after it's due, and make that correction. they'll accept two forms. One is they'll accept it if you factor out the e to the 8x in this case, factor that out and just leave the 40 natural log of x plus 5 over x. That's one thing they'll accept. Or they'll accept if you distribute this through x to this power, I get 40 times x 5 e to the 8x times e to the 8x times natural log of x there. And then over here, what happens is a little tricky here, but the 5, okay, I've got the 5, and then e to the 8x, which is back here. So what's this stuff here? Well, when I multiply x to this power and divide it by x, which is what x to the first power, it looks like this, right? X to this expression divided by x, which is x to the first power. What do we do when we divide like bases, right? The base is both x in this case. When we divide like bases, what do we do? The exponents, we subtract them. So the exponent here minus the 1, that's where this is coming from. So kind of weird looking, but this is what Achieve is wanting. Gets a little tricky with expressions like this to try and get Achieve to accept every possible form of the answer. A little bit tricky there. So I put in a request to have them accept this answer in the future, or see if I can change that. But again, if you have this essentially in there, I will go back after the fact and look at it and make the correction. If you have any questions about this, of course, individually, because your problem might be a little bit different in terms of the numbers, let me know, and I will be glad to talk you through that. Okay, hope this helps. And again, let me know if you have questions about other problems.